Okay, I've rewritten the general solution here. Now let's do something with it. Okay, first step will be a little bit weird for you. Now we're going to replace the free variables y and z. We're going to replace those with letters from the middle of the alphabet. We'll go with S and T. So we'll say replace y, z with S, T. And these are called parameters. You're just changing a letter, so depending on your point of view, this is kind of unnecessary, but we're going to do that. So what do we get? We get x is equal to 2s minus 5t. Y is equal to s. Z is equal to t. Now we have yet another form for our solution. So we'll say this is the solution in parametric form. Okay, you can see it's very close to the general solution. You've just replaced your free variables with what's called parameters. Okay, what we want to come back to is something geometric. So we're going to bring vectors back into it. So we're going to throw this into a vector, okay, a vector x, y, z, and see what happens. So you have your vector x, y, z, which I'm going to call just the vector x. Now what's this x here? Well, it's 2s minus 5t. And then y is s, z is t. Now what am I doing? What am I doing? Okay, so yeah, a bit awkward. This is a 5 and this is an s. Okay, what I'm going to do now is something you're going to find yourself doing a lot in the future. I'm going to take this vector and I'm going to try to pull it apart into a vector involving just s plus a vector involving just t. So what do you get? You get 2s from the first entry, and then you get just s from the second entry, and I'm going to need a 0 here because there's no s appearing here, plus a vector involving just t. So I'm going to get minus 5t. I'm going to need a 0 here because there's no t appearing here, and I'm going to have a t like that. Now that I've pulled it apart into an s vector and a t vector, I can factor out the s here. S 2, 1, 0 plus t -5, 0, 1. And again, this is the vector x here, right? Now, what does this look like? Well, this looks like what I had on the board earlier. X is equal to s times a vector plus t times a vector. So we will perhaps just emphasize that by writing underneath x is equal to s v what did I use? T, S, let's go SW. I believe that's what I did last time, right? Now it looks like a 5. Ugh. S, nice and curvy, nice and curvy. SW plus TV. Okay, where this is W and this is V. Okay, so we have this equation, which we have seen before, but with plus U in front. So you'll remember that this is, when you have the plus U in front here, you had the plane that goes through U and is parallel to V and W. So what we have is the plane through, we don't have a U in this case, so you can think of U as just being the zero vector. So the zero vector is the origin. So the plane through the origin, that is parallel to 2, 1, 0 and -5, 0, 1. So that is our geometric description of our solution set. So we can take the original system, its solution set, think of it as a collection of vectors, and this is how you can visualize them. Now, one more thing. This is very important. It's getting messy here. This is the solution set in vector parametric form. Put a dash, why not? Okay, so there's a lot going on there. We had a system, we solved it. We obtained first a general solution where you have the original variables and you just say that some of them are basic and some of them are free. And then we replaced the free variables with parameters, and we obtained what's called the solution in parametric form, or you'd say the solution set in parametric form. Finally, we did a transformation from here of the solution set, and we threw everything into a matrix. We pulled it apart and we obtained something times a vector plus something times a vector, and this is what's called the vector parametric form of the solution set. And from the vector parametric form of the solution set, you are able to write down a geometric description of your solution set.